Hello, Jane Macon Middle School 8 East Science class. This is your first lecture homework, so I hope you have your notes for work out and ready to be filled out. So this week's lesson is about work. So normally when you hear the word work, you probably think about getting up every morning and going to a job, working all day, just so that you can get a paycheck on Friday. But this is an economics class, so that's not the kind of work we're talking about. This is science class. So what does a scientist mean when they say work? Well, in physical science, work is being done when a force is exerted on an object, causing the object to move a distance. Not that kind of force, though. Remember, in science, force is a push or a pull that changes or tends to change the motion of an object. You may even remember that we have a formula for calculating force. Force equals mass times acceleration. So back to work, not only do you have to exert a force on an object causing that object to move, but the object has to move in the same direction as the force being applied to it. So if you exert a force to the left on a grocery cart and that grocery cart rolls to the left, then work has been done on the grocery cart. In order to calculate work, you have to have both a force and a distance moved. The standard unit, or SI unit, used to measure work is joules. And you will remember we've talked about standard units of measurement before. In science, we work with things that are measurable. So when we measure mass, we use kilograms. When we measure distance, we use meters. When we measure force, we use newtons. And when we measure work, we use joules. So examples of work being done would be lifting weights or any object up off of the ground, pushing a box across a room, or a tractor pulling on equipment. So if you see, when you lift weights or anything up off of the ground, the force is exerted in an upward direction and the object moves up. When you push a box to the right, then you are exerting a force to the right and it's moving in the same direction as the force. If a tractor pulls it on equipment, the equipment is going to move in the same direction that the tractor pulls it. Now, just because you have force doesn't mean that you have work. Just because you have force and movement doesn't always mean you have work. So if you're carrying a bag or another object, you're not doing work on the object. If you hold a baby or another object, you're not actually doing any work. And if you're just sitting in a chair, no work is being done. In the example of carrying a bag or another object, the force exerted on the object is up because we have to hold it up off of the ground. But when we carry it, the direction of movement is forward, not the same direction as the force. So therefore, it's not work. When we're holding a baby or some kind of heavy object, we're exerting a force. We have to, or the object would drop, but it's not moving. It's staying still. No movement means no work. And when we sit in a chair, we're definitely exerting some force on the chair. But because we're not moving, we're not working. So if we want to calculate work, we need the force and we need the distance. And the formula is work equals force multiplied by distance. Again, We're measuring it in joules. Remember, always, always use your units. If you have the units wrong, your answer is wrong. So these are the steps for calculating work. Read your problem thoroughly. Identify the force. Plug it into the equation with the force unit. And remember, force is measured in newtons. Identify the distance and plug it into the equation with the distance unit. Remember that the standard unit for measuring distance is meters, but make sure you're using the correct distance unit for the problem that you're given. It could be feet, it could be inches, it could be kilometers, it could be miles. Make sure you use the right units. Then finally, you're going to multiply the force times the distance. Make sure that you write that correct unit that belongs to the answer. And again, work is measured in joules. So, let's try one. How much work do you think is being done if we were to pull a wagon 4 meters with a force of 425 newtons? So here we have a force that's measured in newtons, 425 newtons, and we have a distance moved, 4 meters. And the force is to the right, the wagon moves to the right, so the force and the direction of movement are in the same direction, so work is being done here. All we have to do is plug those numbers into our formula. Work equals force times distance, which would give us work equals 425 newtons times 4 meters. So I'm going to stop. I'm going to give you about a minute to work that out. Of course, you're sitting at home. You can pull out your smartphone, use the calculator on your smartphone, whatever you want to do, and write in your notes how much work is being done on the wagon. And don't forget to use your units. All right, so let's look at another example. Mike applied a force of 15 newtons to lift a grocery bag 2 meters. How much work did Mike do on the bag of groceries? So we have an upward force of 15 newtons and an upward movement of 2 meters. So how much work is being done? Just plug the numbers into your formula and write your answer in your notes. Remember to use the appropriate units. All right, that is all I've got for you today. I wanted to start out our video lectures with kind of a short, easy lesson. So I hope you got this done. Remember, Monday, first thing, have these notes complete. Put them out on your desk. I'm just going to walk around and see who did it. And if you completed your notes, you've got 100 for your homework for this week. So, I will see you Monday. And you guys have a wonderful weekend. Bye.